Hello all, good morning and good evening. A warm welcome to Global Azure event. So I think my introduction has been nicely done by, yeah. So today I'm going to present about the introduction of Azure Databricks and its capabilities and um, the benefits and performance of the how to use the best practices in Azure Databricks. You can go to the slide. Um, Next slide, Latika. So yeah, today is our agenda. So we can see the points like what is Databricks, why we need to use Databricks, and the features and components of Databricks, and the ingestion to insights and entire architect of the Azure, where the Databricks will fit into the architecture of Azure, and the best practices. Right. So first we'll go with what is Databricks. Yeah. So Databricks was initially built based on the Spark project in 2013. It provides an end-to-end managed Apache Spark platform optimized for cloud, featuring one-click deployment, auto scaling, and an optimized Databricks runtime can improve the performance of Spark jobs more than 10 to 100 times, 100x. And it is simple, cost efficient to large-scale Spark workloads. Moreover, Databricks also includes an interactive notebook environment, monitoring tools, and security controls that make it easy to leverage Spark in enterprises with thousands of users. But whereas, when the Azure has collaborated with Databricks, apart from the all above Databricks resources, it has integrated and collaborated with all the Azure services and full stack of Microsoft Azure. And it can connect to a data lakes, data storage, and Azure Data Factory. And it also a one-click management from an Azure console point of as an Azure portal. And it is very fast, easy, and a collaborative Spark-based analytical platform. It accelerates innovation by bringing data science, data engineering, and all business users together to make the process of data analytics more productive and more secure and scalable. So, and it's simply Databricks is nothing but a cloud-based data engineering tool used for processing and transforming massive quantities of data and exploring the data through machine learning models as well. So as you can see, it offers three types of environments. One is Databricks SQL, and other is Databricks data science and engineering, and other one is Databricks machine learning. Yeah. So can you go to next slide? Sorry. So here we see why we need to use the Databricks. We'll go through this, the benefits. So one is the familiar language. So most of the familiar programming languages used for Databricks are Python, like R, and data processing tools like SQL, and can also used in Spark easily. And some of the modifications should be done to make the package extensions just to interact with the Spark. But for those of us who aren't proficient programmers, right, we can easily switch between the languages. Either if you are an SQL programmer, you can directly switch to SQL, or if you are very professional at data Python, you can shift to Python. So we have that flexibility of writing the code in three languages. And going back to the higher productivity and collaboration. So we have production deployment environments, workspaces, and version control methods. And the third one will go to integrates easily with whole Microsoft Azure stack. So it connects with Azure Active Directory security framework. Existing credentials, authorizations can be utilized with the corresponding security settings. And access and identity control are all done through the same environment. There's no need to separate credentials and everything. And using AD allows the easy integration with the entire Azure stack, like data lake storage, data warehouse, blob storage, and Azure Event Hub. This all is managed by single subscriptions. There's no need to maintain separate credentials, and all are security. Next, extensive list of data sources. I mean, it connects to a very wide range of data sources like flat files like CSVs, JSONs, and the new one, the Parquet files, which is very best in processing big data, billions of or trillions of data. And we can connect to other open sources or MongoDB, RO files, and Couchbase. It connects to various SQL on-premise SQL servers as well. And as you think, Azure Databricks is only for big data. No, it will also use suitable for small jobs too. So for massive, this allows Databricks to be used as one-stop shop for all our analytical works engine. We no longer need to create separate environments or VMs, virtual machines for development purpose or production purpose. And yeah, and it also supports extensive documentation support available, because the programming language Python and they are very ancient codes, so the documents are very well supported in the Microsoft forums to get in any troubleshoot help. Now can you go to next slide? Yeah, so here we are discussing about the features and components. So you can see the Azure Databricks is a combination of Apache Spark, Databricks, and the Enterprise Cloud. All together combines the Azure Databricks. It's in one package. So once you manage the data at scale in the cloud, you open up the massive possibilities for predictive analysis, AI, and real-time applications. So over the past 5 years, the platform of choice for building these applications has been Apache Spark, with a massive community at thousands of enterprises worldwide. So the Sparks makes it possible to run powerful analytics algorithms to compete with the real-time or big data to get the business insight to the end users. However, managing and deploying Spark has remained challenging, especially for the enterprise use cases with a large number of users and strong security requirements. So the benefits for data engineers and data scientists, how it is going to benefit for both engineers and scientists collaborating. So Azure Databricks is optimized for the performance and cost efficiency in the cloud. So the Databricks runtime, right, adds several key capabilities which collaborates with Apache Spark that can increase the performance and reduce cost, and also increase the performance by 10 to 100 times better than the ancient traditional methods. And we have high-speed connectors to connect to Azure storage services such as blob storage, data lakes, Azure Synapse, and even it connect to Power BI. And it has an auto-scaling capability where it can check on its own to reduce or high up whenever it's required. So, and one more is seamless collaborations. Remember, we talk about collaborations. It can integrate even with Power BI as well. So easy to use, total Azure integrations and everything. Yeah, can you go to slide 4? Yeah. So here we are talking about ingestion and insights architecture. So here you can see the data sources in the left side panel, where it has unstructured data sources or structured data sources. When we talk about unstructured data sources, like we have CSV files, we have flat files, we have Parquet files, or we have MongoDB. So what at the end the business required is they'll have the different applications, the source applications. They all need to bring together in one data warehousing model and get them used in the reporting platforms or for the downstream applications. So here, what is the Azure Data Factory and Data Lake doing? So how is the Spark is going to use here? Here the Sparks or Databricks allows to create a transition layer on top of your data lake. This acts as a Delta Lake. So Delta Lake will definitely give a transactional capability, which is like a relational database that has an atomicity, consistency, isolation level, and integrity and durability of the data. So this is available through the Delta Lake. So once you start with the initial load, once you get all the raw data with the different data sources into the Azure Data Lake as a storage layer. So once you brought over here the Azure Databricks comes into picture, and it transforms the we can do multiple operations. Either we can do machine learning, either we can do SQL coding, and all traditional we can do ETL or ELT process in this Azure Databrick transformation. Post that we can send back to the reporting platforms, either data warehousing platforms, to Azure Synapse or any other data warehouse tools, and post that it will connect to the reporting decks, either Power BI, machine learning tools, or any downstream applications. So one example where we can tell us we have a different Excel sheets in the source, and where in target we need to append all those Excels into one Excel. But if it's a traditional way of using, we require one more SQL server and we use staging tables. We need to bring those system, and here definitely there is a huge cost for bringing another additional SQL database or staging tables and everything. So without those, here the Azure Data Lake and Sparks maintain as a Delta Lake to reduce those dependencies, and it also quickly transforms those billions and trillions within less span of time. Right. Can we go to next slide, Latika? So here we talk about best practices. So as I mentioned, Databricks is very easy to work, but it also depends on how do you configure to get the right metrics and right performance to your environment or to your business. So how do we get into the best practices to solve your data problems? Right. So today we're talking about those things like the nodes and cores and memory scaling. So everybody thinks that if we add more nodes and your data will run faster. Yes, data will run faster, but unfortunately, it will also cost more. Right. So if you have more number of nodes in your cluster, it's going to cost you more as well. So like example, we have 4 cores, we can move it to 8 cores or 16 cores. Definitely it will cost you or to the organization. If you add your more memory to 8 GB to 16 GB or from 32 GB to 64 GB and so on, it will definitely increase your cost. But how we are going to really optimize the performance and the cost-based solution to your business? That's the key factor while making Azure Databricks in your enterprise solution. So how do we decide? How do we do? Some of the best practices we are going to explain today. So depending upon the kind of workloads you are trying to leverage in Databricks, you can use different kinds of Azure machines to make up your cluster. So one of the cluster is main for the Azure Databricks. So database cluster, which is nothing but the CPU machines or the DTUs where that give you the database or Databricks environment to process typically for to the system. So let's go with some examples. How do we reduce this? How do we use the best nodes and everything? So if you are going to use some machine learning kind of applications which requires a lot of iterative data, and you're going to use the same data again and again, so it requires a lot of cache. So then you should use the memory optimized machines in your cluster. And some of the machines, some of the Azure environment machines are like DSV machines. Whereas if you are trying to do a lot of ETL kind of jobs and processing jobs or streaming kind of data, where you definitely really need to process the data or incremental row by row operations and does not really need to join, and all this data will not use a lot of memory, but it will use your CPU bound. So for these type of ETL activities, you can use the compute optimized machines. Some of the machines are FS version, VTB, SKU machines. But if you are dealing with high level large data, big data, some billions or trillions of data, so here it will always consume the high IO of the machine or your Databricks. So at this requires high throughput. Like for example, if you're trying to analyze images or doing some add-on queries, or you're using some large tables in Delta Lake, in the Delta Lake, which has billions and trillions. So then all your data is reading from cache, so which will impact your Delta log table. So for this, you need to use a storage optimized methods, machines, LSV versions that going to give you the better throughput and IO intensive operations on those. Depending on the size of the machine, you will able to get the better performance and at optimized cost. So now how we need to optimize the cost, and how many number of nodes or how many number of cores in each node do you need? So we have some of the tools like optimized nodes, Ganglia metrics, and Shuffle, which we'll use to get the better techniques on how to we use. So if you use the Spark UI tool, where it gives you how much of the high CPU the process is using, and you can get back whether the data is the same amount or not. So that based on that metrics, you can tweak your sizing. So in Databricks, if you go and under storage tab, you will be able to see the data usage and how much data is coming from a cache machine versus how much data is coming from the disk. You can see cache versus the disk usage. If you see really the data is fully cached and everything is kind of running from cache, that means you will probably have more number of nodes. Then you need to use an opportunity to reduce the nodes, and so that it will save your cost, and it's not going to affect your performance. So the same way, if you are seeing that data is not fully cached or it's only used at utilized at 50% or 60%, then you can definitely increase the size of the node, or you can use the 16 GB and then increase to 32 GB, so that it will give better performance and you will save the cost at there. And when you are dealing with some large data sets, which is hardly cached, that means, as I mentioned, it will only sit with Delta Lake and that you have on your nodes. We will be better off using the machines with the SSD disk and cache it on the disk. That will give you better performance than trying to increase the size or increase the nodes, because your entire big data is using on your system hard disk or SSD disk. It's not about your nodes. So this will give you some information on the nodes. Now, Spark UA also leverages Ganglia metrics as part of your when you track your CPU utilization or memory utilization or disk utilization. You can use these metrics that to tweak your cluster sizing. So a couple of things like to improve your sizing. When you create your data frames in your Spark code, this data frame is going to create partitions and parallelisms based on the number of nodes you have configured, and it will, in return, good Spark application will scale linearly. So what do I mean is, if you want to double the size of the cluster, it should reduce your processing time in half. Example, if you are using a 16 GB RAM, and if you are doubling your size by 32 GB, so if the earlier was processed in 1 minute, so then the later, after increasing your RAM, it should process in less than 10 seconds or 30 seconds, right? So that's the way you are making the benchmark for your solution. And you should also monitor to see if your application is written good enough by looking at some of the CPU stats. So if you are seeing that the CPU usage is staying above 80, that means the driver of the cluster, you are stressing it on so much. So you need to address that issue as well. And sometimes you can see, sometimes if you are going to see a lot of network spikes, then you should use some SSD based machines, and you can see there's looking at a lot of spills that you should use higher memory machines. So using the Ganglia matrix, you can help to optimize your cluster. So by looking at the optimizing the best way of the cluster. So how do I access the Ganglia matrix? So to access the Ganglia UI, you need to navigate to the metrics tab in the cluster in the left side details page. So there you can see the CPU metrics are available in the Ganglia UI for all the Databricks runtimes. So you can ask your admin or to get the access of this particular Ganglia or GPU metrics. So you can check always this performance. Right now, we can talk about some how do we improve the Databricks performance. So there are three main topics that really look at the performance, right? So one is called shuffle, other is spill, and the third one is queue. So these are the three areas which we should watch out. So there are some tricks we will talk about. So the shuffle is nothing but a process of redistributing the data across platforms. So every time you are using some functions like joins, group by or sorting, or some distinct in the queries or queries functions, each of these functions cause shuffle operations. And shuffle is actually very, very expensive because you are redistributing the data across partitions. And imagine that a lot of data movement needs to be happen for shuffling. So because of this shuffling, so you're using your high system capabilities. So we need to always try to avoid shuffling as much as possible. So what we need to do is, if you are trying some examples, how do you avoid? So if you are trying to join two big tables, so always join the smaller table in the left side and the larger table in the right side. This way, this shuffling will reduce because this is called as a broadcast join, we can say. So what this broadcast join will do is it will join the smaller table first, then the larger table, and using this join, it will significantly improve the performance of this query. And what broadcast point will do is it will take the small table first, right? And this will distribute it across all the executors so that it will not have to do any shuffling of the data because it's starting with small table rather than the big table. So, and one more, next one is spill. Spill is another area that really causes performance low. What exactly spill is? Spill is when the data cannot fit in the memory. So like it will spill the data outside of the disk. When by default Databricks allocates one core per task. Okay, so if you have a lot of cores, because of the spill, it will not allocate all the cores available in the cluster or to perform the task that is needed for the complete query. So that's the reason you will always see the utilization of CPU is low, but still your query is not performing. So many times we debug, we'll check with the admin why it is not working. So the most the reasons for this is the spill. Your queries is taking a lot of your allocations. So that's why you need to always check or how you have to understand how the shuffle affects your environment. So in this particular query, by using shuffle partition, you can see the short performance improvements. Like example, I was doing without normal queries, it will take with 18.5 GB of RAM, and while I changing the shuffle partitions, and I also increased 16 to 48 GB, the same query will complete with a zero spill size. So there's no spill size over here. But I also changed I also shuffled my queries. I also tweaked my tables and everything. So you always look into the most running spill queries as well. As queue is another problem that affects performance. Queue is when the data is not evenly distributed among partitions. So it will downgrade the performance because it's uneven distribution. You will see that initially there is a high spike and suddenly there is no utilization. So to solve this skew problems, either you can use the broadcast joins or skew joins. If still they are not working, then you should probably use some different keys or partitioning your data. Maybe that's wrong with how you did the partition, right? I think this with this I'm concluding my session. So thanks for the session, and if you have any questions, you can let us know.
Thanks, Prashyuth, for the insightful session. Now I'll read the questions for you. So the first question is, should we clean up data frames which are not in use for a long time?
Yes, we should definitely monitor these data frames very frequently or like a quarterly basis. This will definitely increase your cost as well, and this will create a maintenance problem for yourself. Yes, I suggest you clean up these data frames regularly.
Okay, so the next question is, does Databricks works with Azure notebooks?
Databricks works with data notebooks. Yes, Databricks works with data notebooks. So if you see in an earlier presentation in the Azure Data Factory, it also collaborates with Azure Data Factory, and it also Azure Notebooks and Sparks and everything there, and machine learning. These three are part of the Azure native services options in Databricks. Yes.
The next question, I'll read it for you. Can Databricks be used for end-to-end data pipeline? What is the typical time it takes to set up an end-to-end pipeline for a quick POC?
So yes, definitely it will work for end-to-end solution for Databricks because it has everything, native languages, traditional way of methods, and the newer technologies as well. So, and coming to the timelines for a quick POC, it all depends upon what are the uh, features you are going to use. If it's only you are using only very less features like only SQL or data engineering, data science, it will take less than I cannot commit the date or weeks, maybe less than a week or 15 days. But if you're using machine learning as a POC, yeah, it will take definitely some time. It all depends upon what is your POC and what part of components you are including in the POC.
Okay. The next question is, do compressed data sources .csv.gz file also get properly distributed in Apache Spark?
Yes, definitely. Compressed CSV files will also work in the Apache Spark.
Okay. Now, I have one more question for you. So he's saying this might be a silly question, but I know that Lambda exists on AWS, but does it exist anywhere else, such as Azure, etc.?
Lambda. I am not sure about that.
Okay. Thanks, Prashyuth. Thanks for the insightful session. Thanks for giving your perspective on Databricks. Now we will move towards the next session.
Thank you for giving me this opportunity, and it's a great session to interact with the larger audience.